Okay, today we are discussing the 2008.
How does the table go that far? Oh, but you're just not use streaming it.
No, we're not streaming it.
Yeah, like the multipliers is crazy. Like,
And again, I don't have it.
to like tertiaries.
And then I want stop that.
But yeah.
And I want the last 15 minutes for drills.
Oh, drills are gonna fly by.
Okay.
Are they all inside?
I need a 2008.
But where's Koya?
I don't even have it.
He's done.
Oh, because
He's done, yeah. No one.
Right in front of Jason?
No one.
No one.
We're all alone.
Who's in front of that?
No one.
Okay, let's go over this
Next
thing.
to.
Oh, no one has
Hasn't made
Suzaki, you're the very one who needs to pay attention. One.
He's done all of it.
Okay, y equals sine
freaking scared me.
That's all for
y
tonight, Aaron.
2
But
equals.
what is this?
Okay, now this is the area volume problem. You have to nail this. This is the one you gotta nail.
To the wall.
Okay, so the first thing, it says find the area. What integral did you write to find the area? E. What integral did you write to compute this area?
From 0 to sine pi x minus the quantity x cubed minus 4x. Yeah. Oh yeah, sorry.
Okay, see, look, if you put y1 there and y2, then you just write that. You don't have to write all the other stuff, but you have to define it on your paper. And then you get 1 point for the integral, and then you get 1 point for punching it in on your calculator. And we get Kokame? I don't even have any answers for it.
4.
Comes out to 4?
Yeah.
Really?
Yeah. It's beautiful.
That's magic.
It's beautiful.
Of course, that means 4.000, right? If you don't put any decimal places.
It's beautiful.
No?
What happened to 12.110? Is that a wrong?
You had.
Were you in Indian mode?
Oh,
Rating was thrown off so
I
much.
was in the other one.
Wait.
How can anybody at this time be in degree mode?
That's for physics.
Oh,
I spit on physics.
You went in the right direction, actually.
Yeah, Doc's like right downstairs.
No, that's English.
Well, if you're in degree mode, how did the thing even graph it?
so powerful.
Oh, you didn't even graph it, that's why.
Actually, oh yeah, I tried to graph it, but then the thing didn't show up. But I don't,
Yeah,
I
so
just
isn't
got
it like a
graphic
clue? Anyway, we're gonna plant one person. One person is a plant. So on Wednesday, before the test begins, you gotta go, Mr. Brown, do our calculators have to be in radian mode? And then that's the signal for everybody to check their calculator. Who's gonna be the clown to do it? Okay, Teruya, you better. Mr. Brown, do our calculators have to be in radian mode? You gotta do that now.
What's he gonna say?
That's a reminder for everybody.
What if he says it has to be in degree mode?
What?
That's something I've heard.
No, you should raise your hand and be like,
B.
Mr. Brown.
The
is Mr. Park's
horizontal
calculator-
line y equals 2. So y equals 2 is like this. Woo! Right there. Divides it in 2 parts. Write an integral for the part that is below this line. So the first thing you gotta do is you gotta compute these points of intersection, yeah? And you probably want to store it in your calculator. So you probably want to go, okay, this is A. What is the x coordinate of this point? Louis?
But it says do not evaluate.
Yeah, but you
still
don't
gotta
put
write the integral.
limits of integration.
Oh, 0.539.
0.539, did everybody get that? Now what about this point? What's the x coordinate there? Yamani,
1.675.
everybody got that? Okay, so your integral gotta be from A to B. See, if you define it on your paper, then you can just write A and B, but if you don't put it on your paper, then you gotta write it all out. And what integral is, what is the integrand right here? Huang, define this area right there.
Negative 2 minus 1 dx.
So There you go. Top minus bottom. Top minus bottom. It's as simple as that. And then you don't even have to compute it. Okay, part C. The region R is the base of the solid, so we gotta get rid of this now. The region R is the base of the solid. Each cross section is a square, so if I take a slice out of this thing, you're gonna get a square. Okay? Find the volume of this solid. Simao, what integral did you have?
Integral from 0 to 2 of y1 minus y2 quantity squared dx.
Exactly, and then punch it in on your calculator and you get, Chung,
9.970.
everybody got that? I don't see nods, walk a hero. Okay, look, we're perfect so far. D, now some people actually came in for help and asked about this. So if you're a distance from the y-axis, okay, the vertical strip, the depth of the water is given by this. So like, this is the surface of the pond, and then it goes into the board, right? It has a depth, right? So if you were to remove just a single slice of that thing, it would look like this, right? This is the surface of the water, and the depth is what? 3 minus x. Like that. So how do you find the area of this region right here? It'll be, no, how do you find the area of this thing? Length times width. Now this width is the length of the rectangle, so isn't that simply just y1 minus y2? So the area of this rectangle is going to be y1 minus y2 multiplied by 3 minus x. But it has a thickness to it like that, which is dx, and then you simply add up all of these things from 0 to 2, because some people came in this morning and had some crazy integrals. That's the integral there. Okay, so that gave us confidence. Number 2. Okay, concert tickets were sold out within 9 hours, yada, 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 twice differentiable. Okay, use the data in the table. Okay, this one you gotta nail. To estimate the rate at which number you show the computation, and then so this is a 2-point problem. Chin,
150 minus 126 over 7 minus 4.
so just mumble.
Yup.
And what are the units?
People per hour.
People per hour, there you go. That's the easiest 2 points you're ever gonna get right there. Did we get that? Should I simplify that, since I have my calculator? No, you just leave it. Okay, part B. Use a trapezoidal sum with 3 sub-intervals to estimate the average number of people waiting in line during the first 4 hours. Teruya.
Okay, 1/2 bracket.
Okay.
Okay. Then parentheses 120 plus 156.
One what?
120 plus 156.
Oh, I see.
Yeah,
You don't want to put the 1 in the front.
I'd rather not.
Okay.
Then 2, 156 plus 176 plus then 176 plus 126.
Okay, I'm sorry, that's a -1. Because it says estimate the average number of people, which means the average value. You forgot the 1 over b minus a.
Oh, the 1/4. Okay.
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 Come on, when you see the word average, you should be thinking average value. Do I have to put units? No, it doesn't say put units. Okay, from 0 to 9, what is the fewest number of times in which L prime must equal 0? Now, a lot of people got the correct answer. That's 1 point for the correct answer, but are you going to get the other point for the explanation? Lum,
Where did the 1/4 come from?
the average value, 1 over b minus a.
Isn't it 1/6?
No, because it says the first 4 hours.
So from 0 to 4.
Yeah.
Yeah.
So 126 minus 120.
No, average value.
T is
Oh,
from
T. Ah, I see.
Yeah. You guys are scaring me. Okay, what is the fewest number of times, Lum?
3.
Okay, you got 1 point. Okay, but now the explanation. What's your explanation?
Because the L derivative of T.
Oh, derivative.
Derivative
You're
of
gonna be
L.
laughed at the dormitory. You say L prime.
L prime changes signs 3 times.
And then did you show where it changes signs?
With number 9. Or I wrote the numbers on the chart.
Okay, so basically this is what you do. What is the slope from 0 to 1? Just compute slopes.
30.
What's the slope from 0 to 1? 36 over 1. Okay, then what's the next slope?
20 over 3.
20 over 3. What's the next slope? Negative 50. Now see, here's the slope is 6 2/3. The slope is negative 50 there. So again, by the intermediate value theorem, oh, did I start the camera? I better. Yeah. Then the slope gotta hit 0 somewhere in between there, right?
Oh, because of
To get from 6 2/3 to negative 50, don't you have to cross 0 somewhere in between? That's the intermediate value theorem.
You just say L increases.
And how dare, and don't even attempt to put IVT. You have to put intermediate value theorem. And so, what's the question?
Could you just
Right,
write
I know.
L increases, L decreases, L increases?
No.
Yeah, but I think what they're going for is they want you to use the intermediate value theorem. Chin.
So I could just said 3 comma because of the intermediate value theorem.
Yeah, but you gotta show though. Like over here, to get, like you probably should say in words, over here the slope is 6 2/3, over here the slope is negative 50. To get from 6 2/3 to negative 50, you have to hit 0 somewhere in between by the intermediate value theorem. You should say something like that. You guys just want to write as little as possible, is that it? Just put 3 intermediate value theorem. Now that, I don't know, that might get you the points, but I don't, you want to be sure. You have to separate yourself from the other people that are gonna get bad scores. No, I'm serious, you have to
So we're
separate
gonna
yourself.
get bad scores.
Okay, the next slope, what is the next slope? Quick, 24 over 3, which is 8. Oh! To get from negative 50 to 8, you gotta cross 0 somewhere between. Next slope, negative 70. Oh! To get from 8 to negative 70, you gotta cross 0 somewhere in between there. And then what's the last slope? Negative 80. Okay, so not necessarily. So 3 times intermediate value theorem, but then you should explain your answer, yeah? And then D, the rate at which, okay, if anybody got this wrong, go home, cook rice. You are given a rate. How do you figure out how much was done? You do an integral. So this is the rate at which tickets were sold. So to find out how many tickets were sold, you integrate this from, what are my limits of this problem, Suzaki?
0 to 3.
0 to 3, and then you punch this on your calculator and you get
973.
973.1. How come you don't have 3 decimal
Because it
places?
says round to the
Okay, very good, because it says round to the nearest whole number.
decimal.
Okay, now what if you did give a decimal? What if you did? Now, see, I don't know, see, like I said, they don't determine how they grade the paper until they get to the site. And there's only 9 points to play with, so they might not take off the point if you have 3 decimal places. However, they might, you don't know. So how about just read the directions? Okay, are we doing good? Okay, number 3, oil is leaking. I think, didn't we have a problem like this before? Okay, the first problem, they give you the formula. Pi r squared h. At the instant when all of this thing is in, what is the rate and change of the height of the oil slick with respect to time in centimeters per minute? So they want you to find dh dt or h dot. So the first step in a related rates problem is you take the derivative of this thing. Tom, go.
E dot equals pi bracket 2r dot times h plus r squared times h dot.
Excellent, you get 2 points right there, boom! You want the third point? Plug in the numbers. Okay, did you guys plug in the numbers? Okay, and then if you solve for h dot, what did you get? Whose turn is it? Lum?
0.039.
0.039, and do I have to put units?
Yes.
No, because it says, they tell you the units, centimeters per minute. So if you volunteered wrong units, you just got a -1. Anyway, they told you the units in centimeters per minute. Now, some of you, of course, did not even compute this, you just left it as a fraction, yeah, and that's fine, you don't have to. Okay, that's part A. Part B, okay, now a lot of people came in, were asking about this. Now, the key when doing this problem, because they give this problem a lot, like, one of the problems that they had before is people, in fact, didn't we do it? People are going on to the ride, and then they're going off the ride. So there's two rates, so what you wanna do is you wanna look at the total rate. So what should we call the total rate? Maybe we should call it V prime, the rate at which the volume is changing. So what's happening here? The oil slick, we want to find when the oil slick has a maximum volume. The procedure for finding a maximum volume is to take the derivative of volume and make a number line. But see, they don't give you the equation for volume, they're just giving you the rate at which the volume is changing. So what is the total rate that's happening here? Wakahiro, total rate.
400 root t minus 2000.
Okay, is it 400 root t minus 2000 or is it 2000 minus 400 root t?
That way.
Which one is that, first or second?
Second.
Okay, 2000 minus 400, does everybody understand this? Because this is the rate at which the oil is leaking out, but then it's getting taken away at this rate. So you subtract the two and you get a total rate. And then of course, we know how to make a number line, you factor it, and you get 5 minus root t, and we don't need no stinking calculator for this, right? What will make this thing 0? When this is 25, the square root, oh I just gave it away, it's 25. Okay, if you plug in a number bigger than 25, you're gonna get a plus. I think we did it wrong. No, we did it right. You get a minus at this one. And this one's a plus. So the volume is increasing here. And the volume is decreasing there. So the volume is a maximum. So there's a maximum at t equal 25 because whose turn is it? Jordan? E?
Whoa.
The sign of V prime t changes from positive to negative.
Okay, because V prime changes from positive to negative. You must have that phrase there.
Can you just put plus to minus? You don't have to write all positive to negative.
That's what I just wrote.
No, on the AP test, can you?
Yeah, you can put plus. Oh, you mean you're writing out the word plus, you mean?
No, I was writing
Is
out
that an
positive.
answer? No, just do it. Yes, you can put a plus sign and a minus sign. We've been doing that the whole year. Oh my goodness. Okay, justify your answer. So if you have the number line and that sentence right there, then that's your justification. Are we okay on that? Okay, C. By the time recovery device began removing oil, 60,000 cubic centimeters of oil had already leaked out. Write but do not evaluate an expression involving an integral that gives the volume of oil at the time found in this problem. Now, in this problem, if you couldn't figure out this time, you make up a time and you put it in that problem and you can get full credit for part C. You understand what I'm talking about?
You get full credit for it?
Huh?
Even if it's wrong?
Yeah, because they don't want to. They don't want to penalize you twice. That's why. So just make up, or whatever wrong answer you got there, take that answer and put it in there. Okay, so write an expression that gives the volume of oil in the tank. Okay, whose turn is it? Who comment?
60,000 minus the integral from 0 to 25, 400 root 20 dt.
Excuse me? Okay, what's the thing over here? Okay, you started with 60,000 gallons of, it's cubic centimeters of oil. But see, the thing is still leaking and the machine is still taking it away. This is the rate. This is the rate, right? So if you're given a rate, how do you find out how much was done? You do an integral. So the thing that should go here is that total rate, which is 2,000 minus 400 root t. Like that.
Isn't it also plus?
What?
60,000 plus.
Oh, wait. wait, this is the rate at which it's leaking out. That's the rate at which it's being taken away.
How come it's not? I have different.
Wait, now I gotta think. This is how much is leaking out, and then it's being taken away.
This is how much.
So the question is that a plus sign or a minus sign there?
It's a plus.
No, this is the total rate, right?
How come it isn't
That's how much is leaking out.
minus 60,000?
Yeah,
Oh no,
It's
this
a plus.
is how much it started with.
Because
That's
it's
why.
after
It's a
that.
plus.
Because it said it started with 60,000.
Like was right.
It's a plus.
Wait, now the question is that a plus or a minus?
It's a plus.
It's a plus.
It's a minus.
It's a plus.
We're not gonna take a vote now. That doesn't give you the right answer.
Because that's how much is leaking out.
It's both plus or
So we're
minus.
integrating how much leaked out plus what's already leaked out to figure out how much is in the puddle.
Well, because you're finding out how much is
The puddle.
This,
not how much.
yes, you have to minus it.
No, but
No,
you
you
have
have
to
to
add
add
left is more. than
'Cause
how
you've
much
had the
is starting
60,000
with.
leaked
If you
out
have a-
already.
If you have a puddle and you're adding, you add it.
It's a plus. It's a plus.
Best logic.
If you're adding to a puddle, then you're adding to it. Thank you.
Okay, next, what time is it? Okay, we're gonna do the rest, whatever we don't finish today, we're gonna do tomorrow. But, okay, let's just do 4.
I'm sorry, James, I was just an excuse.
Okay, so here is a graph, they give you everything, people. They tell you everything in this problem. 1, 2, 3, 4, 5, 6. This is 6. There's a, oh, this is an ugly picture. There's a horizontal tangent there and there. And they give you the areas. The areas are 8, 3, and 2. Okay, part A. Find both the time and the position of the particle when the particle is furthest to the left. Now, there's actually several ways you can do this problem. One way is, when is the particle furthest to the left? Isn't that the same thing as finding minimum position? Minimum position. And how do you find the minimum of any function? You take the derivative and you make a number line. So the derivative of position is velocity, but this is the velocity. So you just make a number line for it, which is, and what do I put on it? 0. What is this? 1, 2, 3. And that's a 5. And then it's below, above, below. So that means the position is decreasing here. The position is increasing there. And the position is decreasing there. So maximum position, no, we're finding minimum position. Minimum position occurs at either 3 or the endpoint at 6 there. So what they want you to do is they want you to compare the position at 3 and the position at 6, and whichever one is smaller, that's the answer, right? Because we have to find the absolute minimum. Now, how do I compute these things? Well, didn't they say that the initial position is -2? Now, if this is the graph of the velocity, what does the area tell you?
This is
The
travel.
distance traveled. So from 0 to 3 seconds, the particle traveled 8 units to the left. So if you started at -2, where are you going to be at 3 seconds? You're going to be at -10. Okay? And then from 3 to 5, the particle traveled 3 units to the right. So at the end of that time, where is the particle now? -7. And then at 6 seconds, right here, the particle traveled 2 units to the left. So where's the position now? -9. So x of 3 is -10, x of 6 is -9. Which one is smaller? Duh. Right? Okay, B. Or, okay, for how many values of t is the particle at x equal -8? And the answer, oh, you're gonna get 1 point for the answer. What is the answer? Whose turn is it? Yamani.
3,
Why?
because of the intermediate.
Yes. Yeah, because look, to get from -2 to -8, don't you have, I mean -10, don't you have to hit -8 somewhere in between? And then to go from -10 to -7, you gotta hit -8 again. And then to go from -7 to -9, you gotta hit -8 again. So 3 times because of the intermediate values there. Okay, on the interval 2 to 3, is the speed increasing or decreasing? What do I have to look at here, Cho?
Velocity and acceleration.
Okay, so here's 2 and 3. This is the graph of the velocity. Here's 2 and 3. Between 2 and 3, what can you say about the velocity? Since it's below the x-axis here.
Oh, negative.
Is this C or D? This is C. So, between 2 and 3, I guess you should say something like this. Between 2 and 3, the velocity is negative because the graph is below the x-axis here. And then we gotta look at the sign of the acceleration. The acceleration is what? Now, the acceleration is the slope of the velocity. So if this is the graph of the velocity here, what can you say about the slope?
Positive.
It's positive. Acceleration is positive. So since the velocity and acceleration have opposite signs, the speed is decreasing. So whatever I said with my voice, that's what you write down in your paper.
I have a question.
Yeah?
Do you have to justify that it's decreasing or increasing?
Yeah, the justification is because the velocity and acceleration have opposite signs.
Oh, I know. I mean, like, what if I just said the velocity is negative and the acceleration is positive? Is that too general?
And why? Okay, tell me.
Yeah, like, do I have to say why it's
Well, yeah, you should. Why do you say the acceleration is positive?
Because it's increasing.
What's increasing?
The part.
The velocity is increasing. See, you never should use the word it's or the graph or the function. You have to say exactly what. And then part D, during what time is the acceleration of the particle negative? Justify your answer. Well, the acceleration is the slope of this graph, so one way is you could simply make a number line, right? For acceleration. Look at this. Okay, the first thing you look for, where is the slope 0? There and there. So that's 1 and 4. What can you say about the slope from 0 to 1? Look, the graph going downhill. The slope is no negative. The slope is not decreasing. The slope is negative. From 1 to 4, what can you say about the slope? It's positive. And then from 4 to 6, since the function is decreasing, the slope is negative. Okay? And so, of course, now we can answer the question. When is the acceleration negative? From 0 to 1 and then from 4 to 6. Why? Because the slope of the velocity graph is negative. Are we used to that?
Pretty sure V is decreasing at these different rates.
Yeah? Yeah. As long as you said V is decreasing. Yes.
What if I put on my number lines I put 6 like I put 6 as one of the numbers because it ends there or
No.
okay.
Because you're putting things where the slope is 0, because at 6, look, the slope is not 0, yeah?
Okay.
0 and 6 should not be on the number line. Yeah. They are critical points because that's the endpoints, right? But they don't go on the number line, yeah.
And then
How do I write what? Whatever, whenever the slope is 0, or doesn't exist. So isn't, like at 1, isn't the slope 0 there?
No, yeah, but how do you, like, write it out, like, parentheses 0, comma 1?
Oh, yeah, 0 to 1. Well, actually, it does include 0, and it does include 6. You know why? Because right at 0, isn't the slope negative? And right at 6, isn't the slope negative? So it does include 0 and 6, but I don't think they're going to take off a point if you don't include it. They're not going to take off. Question?
do we need a sentence for A?
For
Like,
A?
it says justify your answer, but do we
Well, if you
need-
had this number line and you're comparing the two maximums, then you'll get all the points. Okay, forget the speed, the drills today, because I want to do number 5, because there was some travesties when people came in this morning. Some of us are not even separating them. I guarantee you, if they tell you solve the differential equation, you're going to have to separate variables, people. Okay, 5A, can I just assume you guys can do the slope field? Okay, let's not assume anything. Okay, so at these indicated points, please tell me what the slopes are. Okay, whose turn is it? Yamani,
Um,
is it your turn? This is the,
which point?
okay, first of all, when x is 0, oh, I don't even have it. Okay, so when y is 1, it comes out 0, 0, 0, 0, right? Okay, when y is 2, it's gonna be 1 over 1. Is that correct? 1 over 1?
Yeah.
Yep.
Okay, this is the point 1, 2. What did I just say?
1,
1, 2.
So 1. This is the point 2, 2.
1, 4.
1, 4, so something like that. Okay, this is the point negative 1, 0. So negative 1. This is the point 1, 0. Negative 1. This is the point 2, 0. Negative 1, 4. So it should look something like that. Okay, here we go. I'm assuming we separated the variables. That's the way you solve differential equations. You integrate both sides, and what did we get, Chum?
ln absolute value y minus 1 equals negative x to the negative 1 plus c.
Exactly. 1 point, another point, and a plus c to be determined. Did they give us information to figure out what c is? Did we put the absolute value there? Okay, now, they give you f of 2 is 0, so if I plug in 2 for x and 0 for y, natural log of 0 minus 1, absolute value is natural log 1, which is 0. And if I plug in 2 here, you get negative half plus c. c is a half! Okay, now, we have to solve for y to get the last 2 points. Now, what do I do with this absolute value? What do I do with that absolute value?
Nothing, because the initial value.
Do I
is
leave it
positive.
alone or negate it? When I plugged in my initial condition right here, was the inside positive or negative? It was negative, so you need to negate it. Now, if you don't negate it, you're only going to lose 1 point, so you're still in the running. Minus 1 is not that bad.
Why is it? Doesn't it equal 0 in the initial condition?
Yeah, but zero's not positive.
Yeah, but when you plug in the number
Oh,
here,
0 minus 1.
yeah,
Oh,
to
okay.
determine if you leave it alone or negate it,
Oh.
when you have an absolute value, equals negative x to the negative 1 plus a half. Okay, and how do I get rid of ln? You e both sides. E to the negative 1 over x plus a half, and then all you gotta do to solve for y, put it on that side, bring this on this side, so you get 1 minus e to the negative 1 over x plus a half. Good enough. Okay, and then it says, where are we? Find the limit as x approaches infinity for part c. Now, what happens as x approaches infinity? What happens with this? As x gets bigger and bigger and bigger, this thing gets closer and closer to 0 because the power on the bottom is bigger than the top. Or if you just think about it, you plug in a million, you get negative 1 over a million is close to 0, right? So if this thing gets closer and closer to 0, the whole thing gets closer and closer to 1 minus
1.
what? E to the half. 0 plus a half is a half. 0 plus a half is a half.
We had to do the
That's
work
like
on that.
prenatal math.
Does everybody understand? This gets closer and closer to 0. So 0 plus a half is a half.
Wait, do we have to simplify that?
You can simplify that, that's the answer.
No, not that.
1 minus.
Oh, okay, now, if this had a natural log in it, you would be expected to simplify, but since that's not a natural log, that's perfectly fine. Okay, what time is it? Okay, I don't want to rush through the last problem, we'll save that for tomorrow.
Just add a bunch of zeros into the column you equation.
But, never mind, I'm gonna. 6 and 8. And look at this, they gave you the derivative, it's like, come on. This is not Mississippi. Okay, A, write the equation of the tangent line when x is e squared. Okay, what's the y coordinate? Whose turn is it? Huang. If the x coordinate is e squared, what is the y coordinate? Huang?
2 over
Okay, and then we need the slope. That means you have to plug in e squared into the derivative. Louis? Just read it off your paper. Plug in.
2 over e to the.
What?
No.
If I plug in
Negative 1 over e to the 4th.
Okay, and then just point slope format. Y minus the y coordinate is equal to the slope times x minus the x coordinate. Did we get that? Come on, tangent line should be second nature. Find the x coordinate of the critical point. What is the critical point? When the derivative is either 0 or doesn't exist. Okay, B. So basically, and they're asking whether it's a max or min, so that means we gotta make a number line for f prime. Now they gave you the derivative. What will make that either 0 or doesn't exist? Well, of course the bottom is gonna be 0, but what makes the top 0, Simal?
So
What will make the top equal to 0? You have to go on the side and do this. Uh-huh. So what is it?
0.
E both sides.
Wait, E.
So E. Okay, think of a number bigger than E, like E squared. Plug it in there, it comes up negative. Plug in a number between here and here, like 1, because natural log of 1 is 0, so you get positive. And of course, there's nothing there because the domain of this problem is x is greater than 0, right?
How come 0 doesn't count as a critical point?
Because that's not even a point on the graph. A critical point has to be a point on the graph. Oh, so f is increasing here. What time is it? F is decreasing there. Oh, so the maximum occurs. Oh, they're asking for minimum, maximum, or neither. So there is a maximum at x equal e because what, Chin?
F prime changes sign.
No! F prime changes from
Positive
positive
to
to negative. You cannot just say change sign now, because if it changed from negative to positive, then that means it's a minimum. You have to be very specific for if x is a min. And the graph, okay, we'll do C, the bell's gonna ring already. For C, you just have to find the second derivative. Did you guys do the quotient rule on that? Anyway, what did it come out to? Teruya?
Made of my own.
What?
What?
So what was the point of inflection?
I don't know.
Did you use the quotient rule on that?
I made up my own.
That's a good answer.
Oh,
I got a weird one, so I couldn't simplify.
Tom? Well, it's supposed to come out e to the 3 halves, I think. You know how I remember? We did this for homework. The second quarter, that was the exact same problem. Yes. Okay, I'm gonna do C and D tomorrow. Okay, so tomorrow, you guys better be awake. Because after school, it's gonna be a marathon. It's just, I modeled it after the math team.
We're gonna eat dinner.
No, wait, we're gonna sing some public university band educational system songs. Okay, bring your guitar.
I'm gonna bring it. I'm gonna bring it.
I have to be an hour.
You have to print me out tabs or something.
I'll tell you how to do it. Okay,
They're like,
so you guys gotta start studying this packet.
Do you have any multiple choice?
Yeah, we're gonna, the last one I have is we're gonna do after school tomorrow.
Thanks, Mr. Park.
We get you tomorrow. Oh, look at all these people that didn't come today. I have to email it to them then.
All sides.
Oh,
You could stand outside of their exam and
6, 7 people, I'm gonna have to
You should bring your
email.
base.
Of course, Chen doesn't count. Oh, Chen.
It'll be fun. The 3 of us are gonna jam after AV calculus is finished. The end of period 7-3, we have to do it.
Okay, wait, I'm trying to think.
Let me see. I might just like that. Because I'm not gonna have any class.
You got no classes?
after 8.
Oh.
Well,
Then we might as well do a lunchtime concert.
Yeah.
that's the
You can do all like, what you call it? This, what you call it when there's no singer?
Instrumental.
instrumental.
You don't remember what
You do all instrumental.
Okay, see Mr. Barker.
Okay. Oh! Is that the video's on? The video's still on!